So see this question, ma. So mass of the car is 1000 kg. Clear? So it is moving initially with a speed of 18 km per hour. Clear? Then it has to double its speed in 10 seconds. Then first question is find power delivered by the engine. Second question is to double the speed again. Then the engine should develop how much power. Are you able to understand? Come on, think how you can do this question. So, power is nothing but work done by time, no? Here, what kind of work engine is doing? Is potential energy increasing, kinetic energy increasing? What is happening? Speed is doubling, no? Kinetic energy increases. So, in work energy theorem we studied, no? Work done is nothing but K final minus K initial. This is called work done, no? Work energy theorem. So, this will be the work done in this condition, change in kinetic energy. So, therefore, how can I write? So, power is equals to half mv square minus half mu square divided by time. So, power is equals to half m if I take common, v square minus u square divided by time. So, therefore, power is equals to half into what is the mass of the car? 1000. And final velocity? Okay. So, initial velocity is how much? It is given in 18 km per hour, no ma? How to convert this one into meters per second? So 18 into 5 by 18. So which is equals to 5 meters per second. So speed is doubled, no? So final velocity will be 10 meters per second. That's all, no? So therefore just substituting here. So what is final velocity? 10 square. Initial velocity 5 square and time taken 10 seconds. So power is equals to 500 into 100 minus 25, 75 divided by 10. So 75 5s 75 5s 5 5s 25, 37, no? So 3750 watts. So this will be the initial power. Clear, ma? So we have another question also. Second question is he wants to double the speed again. Now after doubling, what is the speed? 10, no? So 10 from 20 again he want to increase, then what is the power delivered? That's all, no? Now calculate that second one. So for the second one, we shall do here. So power, let it be P1, I want to calculate P2. So half into 1000 into, now initial speed is 10, final speed is 20, no? So 20 square minus 10 square divided by time taken is same, 10 seconds. So P2 is equals to 500 into 400 minus 100, 300 divided by 10. So 1 0, another 0 gets cancelled. So what is the answer we will get? P2 is equals to 15, 1, 2, 3. 1, 2, 3 watts. This is our answer. Have you understood? So, to just increase the speed from 5 to 10, what is the power required? 3750. But to again double, how much power we are getting? 15,000 watts. Clear, ma? So, to continuously increase the speed, we generate more amount of power. That we understand from this problem. Clear? So, see this question. See from here, this is a projectile whose initial velocity is u and it is projected at an angle of theta. So by the time this particle reaches this maximum height at point A, I want to calculate what is the average power delivered by gravity by the time it reaches from here to here. Understand, ma? Similarly, second one, I also want to calculate instantaneous power at point A. What is point A? Highest point. At this point I want instantaneous power, and by the time it reaches from here to here, I want to calculate average power also. Okay, come on. So first let us calculate average power. So yesterday we discussed some formula for average power. What was that? Power is equals to delta W divided by delta T. Clear? So delta W, how can I write? Force into displacement divided by change in time. I can write like this, no? Okay. So then what is the force acting on this body? Force acting is nothing but minus mg, no? Weight of this body. Understand? Then how can I calculate S value? No. S value, displacement. What is the height at maximum position? H max. So H max divided by time. Time is how much? Time is nothing but u sin theta divided by g, no? Why we are writing u sin theta by g? Total time of flight 2u sin theta by g, no? So by the time particle travels from here and reaches the highest position, time will be exactly half, u sin theta divided by g. Are you able to understand, ma? So therefore, and what is the formula for H max? Do you remember? U square sin square theta divided by 2g. That is the height, formula for maximum height reached by a projectile. So u square sin square theta divided by 2g divided by u sin theta divided by g. So square u sin theta and g gets cancelled. So what is the answer I got? Minus mg into u sin theta divided by 2. That's all, no? So this should be my answer for average power. Clear, ma? Then how can I calculate instantaneous power at highest point? Can you say? Instantaneous power formula? dW by dt. Other formula? F dash dot V dash. So F dash dot V dash. This is the formula, no? Or I can write Fv cos theta also. So gravitational force will be acting in which direction? Downwards direction. But at the highest point, velocity is in which direction? This is a projectile, no? Clear, ma? If I throw a projectile like this, this is the path traveled by the projectile. Clear? Here, initial velocity direction is u at an angle of theta. At the highest point, what is the direction of velocity? It is moving in this direction, no? If you draw a tangent at any point to the path of the projectile, that becomes the direction of velocity. So here velocity is in this direction, but gravitational force will be acting in downwards direction. So what is the angle between them? 90 degrees. Cos 90 is how much? 0. So therefore what is my answer? 0 joules. 0 watts. That should be my answer, no? So therefore at the highest point, power delivered by gravity is 0. There is no power. Are you able to understand, ma? Yes, make a note of it. Dear students, so let us see this question. See, a body of mass m is thrown at an angle theta with respect to the horizontal with an initial velocity of u. Then find the instantaneous power delivered by gravity as a function of time. So we are supposed to find out instantaneous power with the changes with respect to time. So let us see how we can solve this problem. So we know that P instantaneous is equals to F dash dot V dash. So therefore how can I write force in the form of vector?
So f dash I can write it is equals to minus mg into j cap, because gravitational force always pulls a body in downwards direction. Similarly, here v represents velocity at any instant of time. So we know that if this is the initial velocity u, this velocity vector always we can split into two components. So this becomes u cos theta and this becomes u sin theta here. So u cos theta will never change because it is in this direction, but gravitational force is acting downwards. So work done by gravitational force on this component will be 0. So u cos theta is always a constant. But u sin theta, initially only u sin theta exists, and after some time this velocity continuously decreases up to the maximum position. From here onwards again the velocity in the y-axis continuously increases. So therefore v dash I can write it as this component in x-axis u cos theta I cap plus, and this velocity I can write it as u sin theta minus gt into j cap. So I hope you have understood how we have written v is equals to u sin theta minus gt here, because vertical component of velocity is u sin theta here. So if body is moving upwards with a velocity of initial velocity of u sin theta, then we know v is equals to u plus at. So final velocity in y-axis is equals to initial velocity along x-axis is u sin theta, and always a is minus g, so into t. So this is how we calculate velocity along y-axis. So this is velocity along x-axis, this total is velocity along y-axis. So therefore this is my force equation and this is my velocity equation. Now I will calculate p instantaneous is equals to f dash dot v dash. So I will write minus mg j cap into, or dot product of, u cos theta into I cap plus u sin theta minus gt into j cap. So we know how to do the dot product of two vectors when they are given in coordinates form. So x1 x2 plus y1 y2 plus z1 z2 will be the equation here. So here I have only component of this force only it is present in y-axis only. So here we have component of velocity which is present in y-axis. So these two we are supposed to multiply. So therefore I will get the answer is minus mg into u sin theta minus gt. So my final answer will be minus mg u sin theta minus minus of minus plus mg square into t. So this is the instantaneous power delivered by gravity as a function of time. So here we have time, so therefore this equation depends on time. Now if I calculate the instantaneous power at the point of throwing this body, so at the bottom point if I calculate, then what I will get? So at the bottom point time was 0. So when I have thrown this particle, so this is the time where I have started calculating the time. So if I substitute t value 0 in this equation, then what I will get? I will get mgu sin theta will be the power delivered at the bottom of the point where we are throwing this particle. Similarly, if I calculate instantaneous power at the top, that is at the maximum height here, then here time taken for the body to reach here will be u sin theta divided by g. So therefore if I substitute here, again if I substitute in this relation, so minus mgu sin theta plus mg square into time for up to here, that is half of the time of flight. So this is equals to u sin theta divided by gt. So see this g and square gets cancelled, so minus mgu sin theta plus mgu sin theta, so totally it should be equal to 0. So this was the same relation which we have just done in the previous problem. So if body was traveling in this direction Gravitational force is acting in this direction. Then here work done is 0. If work done is 0, definitely I can say power delivered by gravitational force is also 0. So this is our required answer, and these are two additional conditions which we are solving here.
Okay, Seema. So this is a mass which is being pulled by an unknown force. Unknown force means what? In the final answer, I don't want F. Are you able to understand? And here the coefficient of friction is mu, and body is accelerating with an acceleration of A. So in a time of t, I want these two values, average power and instantaneous power. Clear? Come on. Try change. I hope you can do this one. Friction is there, no? You have not considered friction here. Okay? So consider friction also. So
Sir, 2 minus mg into 80, sir. 2 minus mg into 80.
No. Let us see. So average power is equals to delta W divided by delta T, no? Clear? So force into displacement into cos 0, because both of them are in same direction, no? So cos 0 divided by time taken. So next, how can I write force equation here? No. So on this body, how many forces are acting? One is applied force F. That's all, no? If body moves in one direction, friction starts acting in opposite direction, no ma? So F minus Fs, this will produce acceleration in this body. That's all, no? Newton's laws. So F is equals to Fs plus ma. And what is Fs here? Fs is nothing but limiting friction in this condition. Limiting friction formula? Mu mg. So mu mg plus ma. So this is the force which I am applying. Are you able to understand? Next, we are calculating average power, no? So displacement equation for total motion, I have to write a displacement equation. Half at square. Initial velocity already given 0, no? So therefore, displacement is equals to ut plus half at square. So displacement is equals to 0 plus half at square is equals to half at square. Now substitute in this relation. So average power is equals to mu mg plus ma into half at square divided by time. So average power, if I take m common, then it is equals to mu g plus a into half at. So this should be my answer. Clear? Then how can I calculate instantaneous power? F dash dot v dash, no? Or I can write Fv cos 0, because force and velocity both are in the same direction. Clear, no? So force is same. Force just we have calculated, no? So mu mg plus ma. Now what about velocity? Velocity after a particular time of t. V is equals to at, no? At. So just multiply these two equations. F instantaneous is equals to m into mu g plus a into t. So this is our answer. Clear? So see, what is the difference between this average power and instantaneous power?
Average power is total power, sir. Not cooled, sir.
How much it is?
Half.
Exactly half. This one is greater. So this is the instantaneous power exactly after a time of t. But this is from starting to a time of t, total average we have taken. Have you understood? That's so see this question, ma. So power of a water pump is 400 watts, but its efficiency is only 75%. What is meant by efficiency is 75%? It means out of the total 100% power it can generate, 25% will be lost as other forms of energy. Heat energy, sound energy, vibrational energy, all these kinds of energies. So it can generate only 75% of its rated power. That is the meaning of that. So it is employed to raise water by 40 meters. It has to take water to a height of 40 meters. Then how much volume of water it can take in a time of 10 minutes? That is the question. Clear? Come on. Time 10 minutes, no? That is our answer. Clear? Sima, initially, first I want to calculate what is the effective power, no? See, in any engine, total efficiency cannot be utilized. Definitely there will be some wastage of power. So here the wastage of power is 25%, which is not possible. Generally efficiency will be less than 40% only. Just he gave like this. So effective power is 300 watts. Clear? Next, this pump is doing what kind of work? Many kinds of work are there, no? Work done by friction, work done by spring, kinetic energy, potential energy. All these are kinds of work only. Here what kind of work? Potential energy. So it is taking water from here to a particular level, no? So just height is increased, that's all. So therefore, potential energy of the water is increased. So mgh divided by time should be our answer. Clear, ma? But he is asking volume of water to be lifted, no? Where is that? Volume. So from mass, how can I calculate volume? We have this relation, no? Density is equals to mass by volume. So mass is equals to density into volume. So instead of mass, if I substitute rho into V, then I will get volume. And what is density of water? 1000 kg per meter cube into V. So substitute here, then remaining all values I have, no? So that should be our answer. Clear? So if I calculate this one, what is the answer I should get? 0.45 meter cube. Okay? So this much volume of water will be lifted with this efficiency. Understand? Same question, I want to solve it in a different method. So not only taking it to a height of 40 meters, after taking to a height of 40 meters, velocity of water should be 10 meters per second. Then how much volume of water it can take? This is my question, second question. Have you understood the second question, ma? In this condition, what is happening? Water was here, no? So just this water was taken from here to a height of 40 meters. It means initial velocity of water is 0, final velocity also 0. Just water is lifted, that's all. Understand? Now in the second question what we are studying, it is not just lifted, but after reaching to a height of 40 meters, water has some velocity also. Velocity of how much? 10 meters per second. Clear, ma? Then how much volume of water this motor can lift with the same efficiency of 400 watts? This is the second question. Clear? Think how you can do this one. How to do this problem? Any idea? Time 10 minutes, no ma? So, from this only unknown quantity is V. That should be my answer. So, let us call it as V dash. So, can you say what is the meaning of this formula? Yes, this power is this engine. Now it is doing two works, no? It is not only lifting water from here to here, it is giving certain kinetic energy also. So motor is doing two works here. What are they? One is lifting the water, that is providing potential energy to water. Another one is giving kinetic energy also to water. Clear, ma? So total work done is mgh plus half mv square divided by time. And how much velocity it is providing? 10 meters per second. So just substitute all the values, and v dash is the only unknown quantity here which I have, no? So solve that one, that should be our answer. Clear? Now you calculate v dash and see whether it is less than this v or greater than this v. Which we got is 0.4 meter cube of water it is lifting. Okay? So when kinetic energy is also given, then volume of water is lifted is less than when I have lifted only to raise the potential energy of water. That point we can understand. Okay? Okay, see, I will explain this one. So a truck can move an inclination which is 1 in 50. What is meant by 1 in 50? So height is 1 and distance is 50. So length of the inclined plane is 50. Are you able to understand? So it can move upwards with what speed? With a speed of 5 meters per second. And the resisting force, whatever may be the resisting forces, they are how much? 1/25 the weight of the truck. Clear? So this is our condition. Now the question is, with what uniform speed the truck can come down with if it generates same amount of power while coming down also. Are you able to understand? For moving upwards, it can go with how much speed? 18 km per hour. And for coming down also, it has to use the same power. Understand? Then with how much velocity it can come down the plane. That is the question. Clear? Come on. Resisting forces means work done, force due to friction, force due to air. Whatever may be the forces which are in opposite direction to the motion of the body, they are called as resisting forces. Clear? Come. See now. So this is the inclined plane. So what is meant by 1 in 50? This height is 1 and length of this inclined plane is 50. That is the meaning of 1 in 50. Clear, ma? Or directly you can say sin theta also. So if this is theta, sin theta is opposite by hypotenuse, no? So 1/50 is also called as 1 in 50. Are you able to understand? Okay. So initially, this truck, it was moving on this inclined plane. Understand? It is moving with uniform velocity, no ma? Uniform velocity of 18 km per hour. Uniform velocity means what?
Uniform and same speed that what is the shape?
Means what? Acceleration is 0. That's all, no? So acceleration is 0 means again what? Upward forces and downward forces are equal. That's all, no? So if a body is present on an inclined plane, how many forces will be present on this body? One is the force which is pulling this body upwards. Understand, no? And one more force, mg sin theta, it will be pulling the body downwards, no? If I split weight of a body into two components, many times we have done this one, no? So if this is angle theta, if this is mg, then this mg I can always split into two components. That's all, no ma? So mg sin theta and mg cos theta. Are you able to understand? What is the function of this mg sin theta? It always pulls the body downwards. Clear? So he said that there is one more force also, no, which is called resisting force. So let us call it as friction. So two forces are downwards and one is the force which is pulling this body upwards. So these two forces must be balanced, no? Then only body can travel with uniform speed. Clear? So therefore what can I write? I can write F is equals to mg sine theta plus friction. Okay? So mg is nothing but weight of the body, no? So W sine theta value 1 by 50. So W by 50, can I write like this? Mg means weight only, no? Weight sine theta value opposite by hypotenuse, 1 divided by 50. Clear, ma? Next, how much is the resisting forces which are present? 1 by 25th the weight of the truck, no? So W divided by 25. Understand? So if I take LCM of these two, then what it will get? 50. So W plus 2W is equals to 3W divided by 50. So this is the force which I have to apply to make the body move with same speed. Understand, ma? So therefore I can calculate power, no? F dash dot V dash, and force and velocity, both of them are in the same direction. So therefore what can I write? Fv cos 0. Force is how much? 3W by 50. And what is the velocity? Velocity is 18 km per hour. So this is our equation number 1. Understand? So here we are not converting into meters per second because there is no need of converting. Final answer also I will get in terms of kilometers per hour only. Clear, ma? Okay. Now what is the condition he gave? This truck, now it is coming down, no? Now it is coming down. Are you able to understand, ma? So he is saying that it is coming down with the same power. But he is saying that it should come with uniform velocity of V dash. How it is possible? This is my question. Clear? For moving upwards, he is continuously opposing two forces, no? Mg sine theta and friction. Then it is able to travel with uniform velocity of 18 km per hour. If he uses the same power downwards also, he should accelerate, no? His velocity should continuously.
V0, sir.
V is not 0. It is coming down with uniform speed. That is what he gave, no? With what uniform speed the truck can come down? This is the question. If he uses the same power for coming down also, he should accelerate actually. His velocity should increase. But how he is saying that he has uniform speed? That is the question. Which force is opposing? So W by 25 is the force, no? Opposing force. Okay. But he is applying more power, no? Okay. See, here the condition is, see, ma, on this body, how many forces are acting? 3 forces. So one force is a frictional force, no? How much it is? W by 25. Another force which is acting always downwards is mg sine theta, no? Mg sine theta is nothing but W divided by 50. Understand, ma? So out of these two, which is a bigger force? W by 25 is a bigger force. It means that body cannot come down only with the help of mg sine theta. That is the meaning of this one, no? With the help of only mg sine theta, body cannot come down. Therefore, what it will do? It will apply a force of another force which is called F dash. Are you able to understand, ma? So because friction is greater than the component which is pulling the body downwards, body cannot come down by itself. It has to apply some downward force. So therefore, these two must be equal to W by 25, no? Why these two are equal to this force? Because again it is given that body is coming down with same velocity of V dash. That's all, no? So therefore, how can I write a relation? F dash plus W by 50 must be equal to W by 25. That's all, no? So F dash is how much? W by 25 minus W by 50. So how much 50 if I take as LCM, then it is how much, ma? So 2W minus W is equals to W by 50. That's all, no? So this much force I have to apply to make this truck to come down. Understand?
So he is asking velocity, no, but with the same amount of power. Initially, what was the power equation we derived? 3w by 50 into 18. Here also he should use same power. So power is how much? 3w by 50 into 18 is equals to f dash into v dash. That's all, Rama. New force and new velocity. What is the new force I got? W by 50, no? So 3w by 50 into 18 is equals to f dash value is w by 50 into v dash. So w gets cancelled, 50 gets cancelled. So v dash is equals to 18 3s are 54 kilometer per hour. That is our answer. Understand, ma? So if he is using the same power to move upwards, then what is his velocity? 18 kilometer per hour. If he uses the same power to come down, then what is its velocity? 54 kilometer per hour. Have you understood why it is not accelerating? It is not accelerating because frictional force is greater than weight component, mg sin theta. So therefore we have to apply some additional force to make this body come down the plane. Dear students, so let us see the next question. A constant force F pulls the block of mass m placed on a horizontal surface. If the coefficient of kinetic friction between the block and the ground is mu, find the power delivered by the external agent after a time of t, measured from the beginning of action of force. So here we will try to calculate both instantaneous power as well as average power generated by this source. So let us try to draw a diagram of this one. So this is a body of mass m and a known force F is acting in this condition. So coefficient of friction is mu in this condition. Then we are then after a time of t, we are supposed to find out the power delivered. So first let us see how we can calculate average power. Okay, so P average is equals to delta W divided by delta T. So force into displacement divided by time taken. So force is already given. So force is F in this condition. And displacement, let us see how we can calculate displacement. So displacement we know because here a net force is acting on this body. So displacement should be an accelerated displacement. So S is equals to half AT square. But A value is not given in this condition. So first of all we are supposed to find out A value. So A is equals to F net divided by M. So here on this body two forces are acting. One force is the applied force, another force is limiting friction which is pulling this body to the other side. So net force become Fs minus F minus mu s mg divided by m. So this will be the net force and this is the acceleration which is produced in this condition. So therefore now I will calculate average power. So P average is equal to force into, and here force into displacement into cos 0 I can write, because force and displacement are in the same direction. Cos 0 value is 1. So F into F minus mu s mg divided by m into half into t square. So force into acceleration into half t square. So this should be the power, and here again we have divided by t. So t and square gets cancelled. So the answer which we should get is average power is equal to F into F minus mu s mg into 1 by 2 into t divided by m. Or I can write average power is equals to 1 by 2 into F minus mu s mg into t divided by m. That should be our answer. Now let us see how we can calculate instantaneous power. So we know instantaneous power is equals to F dash dot V dash. So again I can write Fe into cos 0. So force applied is F only. Now we are supposed to find out final velocity after a time of t. So after a time of t, we know final velocity is equals to v is equals to u plus at. But here initial velocity we are taking to be 0. So v is equals to a into t. And acceleration already we have calculated. So therefore v is equals to f minus mu s mg divided by m into t. So this is my final velocity. Now just substitute in the relation of instantaneous velocity. So P instantaneous is equals to F into V. V value is F minus mu s mg divided by m into t. So this is the answer which we got. Now if you compare average power and instantaneous power, so average power is just half of the instantaneous power which we got. So initially at the starting of motion, instantaneous power was 0, and at the end of the motion, that is after a time of t, so this will be my instantaneous power. If you take the average of the instantaneous power at the starting and ending, that should give my average power, which is exactly the same answer which we got. So this is how we can solve this. So let us see this question. So an automobile of mass m accelerates from rest while engine supplies constant power. Find the velocity and position of automobile as a function of time. So this we are supposed to find out. Let us see how we can do this problem. So it is given that power is a constant here. So therefore either you can use the equation of instantaneous power, or you can use the equation of average power also. So I will use this relation here. So F P is equals to F dash dot V dash, and if they are in same direction, directly I can write F into V here. So this I can write, and this F again I can write it as mass into acceleration into velocity. And acceleration can be again written as A is equals to dV by dt into V. Why we are converting like this? Because velocity I want to calculate in terms of t. So acceleration also I am trying to convert in terms of velocity only. So therefore if I rearrange this equation, I can write V dV is equals to P by m into dt. So this is how velocity is changing with respect to time. Now if I want to calculate total change in velocity with respect to time, then what I can do? I can integrate on both sides. So integration and integration, and here limits of integration are 0 to v, and here p by t is changing with respect to dt here. So therefore I will write 0 to t in a time interval of 0 to t. And here p by m is a constant, we know, so we can take it outside. And integration of v will become v square by 2, and limits are applied from 0 to v. So p by m is a constant, so we can take it outside. So p by m into integration of dt, limits are applied from 0 to t. So v square by 2, if I apply the limits also, then also I will get the same relation. So is equals to p by m into, now this integration and differentiation, as they are reverse processes, they get cancelled. So I will get t here, and if I apply limits also, I will get the same equation. So therefore v is equals to 2pm by 2p by m into t per whole root I can write. So therefore v is equals to root of 2p by m into t power 1 by 2. So this is the relation between velocity and time, or we can say this is how velocity is changing with respect to time. So now I want one more relation also. He is asking position of automobile as a function of t also. So very easily I can calculate, because already I got the equation for velocity here. We know velocity is equals to dx divided by dt is equals to square root of 2 pi by m into t power 1 by 2. So therefore, how can I write? I can write dx is equals to square root of 2p by m into t power 1 by 2 into dt. Now if I want a total position, that is total displacement in a time of t, then again I will integrate on both sides. Here limits are applied from 0 to x, and this we are integrating with respect to time, so limits will be 0 to t here. So again this integration and differentiation, they get cancelled, so x is equals to, and 2p by root 2p by m is a constant, so root 2p by m into, and now integration of t power 1 by 2 will be equal to t power 3 by 2 divided by 3 by 2, and limits are applied from 0 to t, so I will get the same limits here. So therefore x is equals to square root of 2p by m into 2 by 3 into t power 3 by 2. So therefore I will take this 2 inside, then it will become 4. 4 2s are 8p divided by this 3, if it goes into the square root, then it will become 3 3s are 9, so 9m. So therefore is equals to square root of 8p divided by 9m into t power 3 by 2. That should be my answer. So this is the given question. A constant power P is supplied to a car of mass 3000 kg, and velocity of the car increases from 2 meters per second to 5 meters per second. When the car travels a distance of 117 meter, find the value of P. This is the question. So now previously we have done some problems based on some formulae. So here velocity of the body is changing from 2 meters to 5 meters per second. So can I use P is equals to W by T is equals to half mv square minus half mu square divided by T. This formula I have. Similarly I have P is equals to F into V. Now can I say that these two equations are applicable in this condition or not? So let us see. So this equation of work done, this was basically derived from work energy theorem, which says that, so according to work energy theorem, let us see how we have got this derivation. So work done is equals to force into displacement, work done is equals to mass into acceleration into displacement. So therefore how I got, we have v square minus u square is equals to 2as. So therefore as is equals to v square minus u square by 2. So w is equals to m into v square minus u square divided by 2. So therefore w is equals to half into m into v square minus u square. So w is equals to half mv square minus half mu square. So all these derivation we got derived by considering the condition that force is a constant. But in this condition, is force a constant or not? So let us see, if I take this relation, power is equals to F into V. So if force is a constant, but here velocity is continuously changing, and it is given that power is a constant, so P should be a constant. So therefore if velocity increases, force should decrease, then only power will be constant. So therefore this derivation, which was derived based on the condition that force is a constant, this we cannot use. So therefore we will use the relation power is equals to F into V is equals to, F can be written as mass into acceleration into velocity. So therefore as we don't know acceleration, and acceleration is depending on the distance covered by the body, that is 117. So how we can write this relation? We can write A is equals to P divided by mv. So for A we have two relations, dv divided by dt and also v dv divided by dx. So out of these two I will prefer this one, because question is framed on displacement here, that is 117 meter. So according to this, how can I rearrange this equation? I can write v dv is equals to v dv by dx is equal to p divided by mv. These two I am equating. So after this how can we write? I can write So this v I will try to send on this side. So v square into dv is equals to p by m into dx. I can write like this. Now velocity is changing from 2 meters per second to 5 meters per second. So therefore I will integrate this one to calculate the total change in velocity. So I will apply the limits of integration. So this is initial velocity, this is the final velocity, and x value, let us suppose that it is changing from 0 to x, and x value we know it is equals to 117. So integration of v square, we know it is equals to v cube by 3, and limits are applied from u to v. So is equal to, and p by m is a constant here, and integration of dx will give x here. So p by m into x. So therefore, if I substitute the limits here, then this is the equation we will get. So v cube minus u cube divided by 3 I am taking out of this brackets. So this should be equal to px divided by m. So therefore, p can be written as m into v cube minus u cube divided by 3x. So if I substitute all the values, then mass is 3000, final velocity is 5 cube, initial velocity is 2 cube, divided by 3 into x value is 117. So p is equals to 3000 into, so this is 125 minus 8 should be equal to 117 divided by 3. So power is equals to 1000 watts. So this should be. Dear students, so let us see this question. So here a particle of mass m is moving in a circular path of constant radius r such that its centripetal acceleration is varying with respect to time as k square r t square, where k is a constant. The power delivered to the particle by the force acting on it will be given by which equation? That is the question. So let us see how we can solve this problem. So if a body is traveling in a circular path, then centripetal force will be acting towards the center, and centripetal force is given by k square r into t square. So that is, centripetal force is directly proportional to t square. So it means that centripetal acceleration varies as time varies. That is, if time increases, centripetal acceleration also increases. And we know that centripetal acceleration A is equals to v square divided by r. R I can write v t square divided by r. So centripetal acceleration is directly proportional to v t square also. So it means that as a tangential velocity increases, then centripetal acceleration also increases. So therefore, if body is present here, then how can I increase its tangential velocity? So if initially this is the velocity, and if I start applying force in this direction, then I can say definitely its tangential velocity increases. Similarly, if body is present here, and if it is moving in this direction, then I have to apply force in the same direction. Then definitely its tangential velocity will increase. So therefore centripetal acceleration also will increase. So it means that he gave that force is a constant here. Power delivered to the particle by the force acting on it is given by. It means he is saying that force is a constant. So therefore we know power is equals to F into V. So therefore, as this velocity, which velocity? Tangential velocity, if it should increase, and power remains, then force remains constant, then power delivered by the system also should increase. So this is increasing, this is a constant, so therefore power also increase. So therefore I can say power also it should increase with respect to time. So here we take this formula, which will be the equation for instantaneous power delivered. So now let us see how we can solve this problem. So we know power is equals to force into velocity, so which is equals to I can write it as mass into acceleration into velocity. Now which acceleration and which velocity? So we are increasing A tangential velocity and V also tangential velocity. Now the given equation is centripetal acceleration which is given. So AC is equals to k square r into t square. So we know AC is equals to V square divided by R, or V tangential square divided by R. So VT square is equals to k square R square into T square. So Vt will be equals to k into R into T. So one equation I got for tangential velocity. Now how can I calculate tangential acceleration? So I know that tangential acceleration is equals to dvt divided by dt. So this we know. So therefore d by dt of, and tangential velocity is how much? K into r into t. So kt is a constant, I will take it outside. So therefore I will get A tangential is equals to kr into dt divided by dt. So which is equals to k into r. So this will be my tangential acceleration. So therefore now I can substitute in this relation. So therefore power is equals to m into A tangential acceleration is kr into tangential velocity, I got it as k into r into t. So power is equals to m into k square r square into t. So that should be our answer. So the power P supplied to a body initially at rest varies with the time as P is equals to kt square, where t is a constant. So the velocity of body at any instant of time will be proportional to dash. That is the question. So here let us see how we can solve this problem. So here it is given that P is a variable here, power is a variable. So therefore we have to use the concept of instantaneous power. So P is equals to dw divided by dt. So this I can write dw is equals to p dt. So if I want the total work done, then I have to integrate on both sides. So integration differentiation cancels, and the total amount of work done will be nothing but half mv square. Because initially body was at rest position, and finally if its velocity has increased to v, then we have to write w is equals to integration of p dt, and the total amount of work done is half mv square minus half mu square according to work energy theorem. So integration of p into dt. So here initial velocity is 0, so therefore I can write half mv square is equals to integration of p value is given as kt square into dt. So if I integrate this one, then what is the result I am going to get? So therefore half mv square is equal to k into t cube divided by 3. So therefore I will get v is equals to square root of 2 by 3 into k by m into t cube. So that should be our answer for velocity as depending on